fine. Yeah, you should just.
Okay.
You can just. Yep.
Okay. Welcome to the biggest meetup space with the smallest screen. Yeah. So I guess if you can't see anything at one point, just yell and I will read it for you. Also, if you can't hear me, just yell and I'll speak louder, I guess. Anyways, my name's Kenneth, and I'm a front-end developer here at Linkfire. I'm also an avid contributor to Ember.js, the framework you last heard about 7 years ago. And I'm also the editor of Ember Times, the official Ember newsletter that I make together with the core team. And I also have some internet access, so you can find me there as well. That's Comic Sans, by the way. That means that we're a cool young company. You didn't see it? There we go. Yeah, so that's good. So I'm here to talk a bit about Glimmer. And just a show of hands, how many of you know what Glimmer is? Yeah. How many of you know what React is? Nice. Okay. Yeah, so I mean, when I say how we use Glimmer.js, it's more like what the hell is Glimmer? And then lastly, how do we use it? So I'm going to take you through a bit of history here. What is Glimmer? How does it perform? Because that's one of the important aspects of Glimmer. And then lastly, how do we use it here? And I was a bit worried that some of you might get a bit bored with some of the low-level things here. So I tried to make this as exciting as possible with some sick-ass transitions. So in case you're bored, I got you covered. So what is Glimmer? Well, the official definition is it's a JavaScript component library that's like super fast and lightweight, and it's really nice. And yet another component library in JavaScript. And to get started, it's quite easy. You can utilize the Ember CLI to just generate a new app with the Glimmer blueprint, and then you have like scaffolded an entire project. And then you can use the Ember CLI to like generate components as well. It'll do everything for you by magic. And I thought that it would be a very bad idea to live code this for you, so that's what I'm going to do. So I think we're just going to start out by making a small Glimmer application and then see what goes wrong, basically. So somewhere I have a terminal. Okay, can you all see this? Perhaps? Can you see this now? Yeah. Okay, so I'm running the blueprint for a new Glimmer.js app with the Glimmer blueprint, and with this bad boy, it's going to take a while. Also, there's an npm step in this, so I thought that I could entertain you while you're waiting with some cool questions. How many of you know about Ember? Yeah. How many of you know about Vue? Okay, yeah, that's not good. So it scaffolds a project for me with some components and some tests and just basic setup. It initializes a Git project, and it's installing dependencies, which, yeah, you know, it's never fun. There we go. So I'm gonna go in here, and now we have the project structure of the app running. So it's basically ready to whatever we want. So I think let's start by creating a component. Let's say we want to make a component that tracks the attendees of Copenhagen.js, right? So this is an Ember CLI thing for generating new stuff. So it'll just take care of all the boring stuff for you. It created a test for me and the component itself, right? So I can do this. And that looks weird. Okay, let's see if it works. So we will start with component and whoop, 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 like this. Okay, so let's start with our template. We want a nice header, and we want there's attendees. right? And we want a button to add more people. All right. Nope. So gonna have an action called increment. Add people. And that's all nice, right? So we have some dynamic content and we have some static content. And you might be thinking, do we need a button to remove attendees? But I can tell you, you're not leaving this room. So, right. Then we have the component itself. We want the attendees dynamic part. So in Glimmer, we track this like this. And let's just set it for 10. It's an initial thing. Then we increment, whoop, like this. I can see shit. That's not right. Can you see anything? Can you see my cursor by any chance? There we go. Right, and we just add a person here. And we have to remember to import stuff. So, like this, we've built a base component that can add an attendee to an event. So let's try running this with Yamper server, and hopefully this works. Yep. So if I can get the screen to work. Okay. Let's try this. Nice. So one of the good things about using Firefox nightly is that it, well, installs a new version every time you launch it. But here we go. There's a basic app. We can add people. And that's basically how easy it is to get started, at least, building your application. So in a few minutes, we have a working app. I think that's pretty cool. But that's, yeah, thanks. It worked. Right. So, but the more important thing is, well, how does it perform? Like, that's the key thing about frameworks and component libraries these days. Don't care about, well, you care about if Facebook made it, but how does it perform, right? That's the key, and I promise you it's fast. No, it is fast. We're going to have a look at it. So one of the co-creator is called Tom Dale, and he made like some demo videos of like comparing this to React or whatever. So we're going to have a look at a video comparing a really shitty React app with a really shitty Glimmer app. So it's made to fetch like 50 Wikipedia articles and render a lot of components at the same time on a Samsung Galaxy 3 with horrible internet. So it's only gonna, well, it's not gonna end well. So like this. And what you'll see here is, well, both are pretty crappy because it's not nice circumstances. But what you'll see is that Glimmer in this case performs just as well as React, which I think is pretty cool. I mean, that's nice benchmark to have. React is really performant. So I think that's nice. So how is it this performant? Well, there are three things that it provides, like instant templates, optimized updates, and then 60 frames per second incremental rendering. And if we start with the template stuff, we can see that, well, there are two important things here to consider: file size and parsing. So file size is obviously important when you have your users have to download your entire JavaScript library, and if they're in Brazil on a Samsung Galaxy S3, it's not going to be very fun often. So if you look at React, for example, it's just a popular frameworks. I'm using that as an example. This would go for a lot of stuff. You have JSX on the one part, and it compiles to JavaScript, right? That's pretty basic. One thing about that is JavaScript doesn't scale super well. So when you start having a large amount of JavaScript, the normal suggestion is, well, you should write less JavaScript, and then it's super performant. And that's not always super easy to do. So what Glimmer does, and which I think is interesting, it takes, so this is a similar component in Glimmer component. It has this idea of the browser should not do a lot. So what it does here is it transforms it to bytecode, which I think is pretty cool, because the compiler takes the component, turns it into bytecode that the browser can understand, and this bytecode is specialized to work with JavaScript and the DOM. So basically, it sends this into a VM in your browser, small JavaScript VM, and this does a lot of great things with file size because it's bytecode. It's not JavaScript, and that's how I feel about it. It's pretty cool. Yeah. So, well, what about parsing then, right? I mean, one thing is download, and that's usually the benchmark we have. How long did it take to download this whatever JavaScript in your browser? And it's usually the thing we talk about because parsing, a lot of people think parsing is free, right? It's just this small thing that has to be done. But it's not completely true. For example, it depends a lot on the language it's passing. So JSON is like 10 times faster to parse than JavaScript, for example, in the browser. So the good question is, what about bytecode? So can anyone here guess like how much faster bytecode would be to parse? There is no parse. That's what's pretty amazing about it. Like there's literally no parse, and that will always be faster than, well, whatever, right? I think that's pretty cool. Then we have like optimized updates. So if you've used React or any other framework before, it's pretty cool until your app grows, and then you have a couple of junior developers who try some cool things, and all of a sudden you end up like this, right? Stuff happened, re-render everything all the time. And you end up here if you're not careful with these frameworks, right? You safeguard yourself to not unnecessarily re-render stuff that doesn't need the re-render, but when it happens, it causes performance issues. So what Glimmer does is also pretty cool, I think. Basically has two VMs. So it has a VM for appending stuff and for updating stuff. So when the append VM is like creating the DOM, everything, pushes stuff. When it finds dynamic content, so for example, the attendees kind of the dynamic part, it tells the update VM, hey, watch this stuff, this is going to change. So when change is happening, it's only updating that part. It's not redoing everything in the DOM. It's not watching anything else. It only cares about stuff it needs to update. And that actually leads to 6 times less time spent on re-rendering stuff. And yeah, it's pretty cool if you want VMs in your browsers in JavaScript, by the way. But what I think is sort of more mind-blowing, at least it was for me, is the 60 frames per second incremental rendering. And it sounds super boring, or like a game setting in Counter-Strike. But basically, the browser renders stuff in frames, so frame by frame. And the ideal case is to have 60 frames per second. To achieve that, you need just about 60 milliseconds per frame to have a nice experience. And if you don't have it, you end up with this white rectangular, as you saw in the demo, while the app was loading. There's nothing until it's done with that frame. And that's because we usually do stuff like this. So we do everything in the first frame, and then the rest is nice and responsive and whatever. And it can be hard to optimize for this, because with JavaScript, how do you sort of split this stuff? How do you ensure that 60 milliseconds per second per frame is what we do? It's pretty hard. But the cool thing about bytecode and VMs is that we can sort of predict the stuff. So what happens here is it knows what needs to be done. It knows everything from the bytecode. So we can split all actions into 60 milliseconds per frames. So you always ensure that you don't spend more than 60 milliseconds on each frame, which creates, I mean, it doesn't look like much, right? This looks like, meh, okay, one frame just got a bit better, but I promise you, you can see the difference. So if we think back to the example before, the demo with the two applications that were sort of equally slow and shitty, that Glimmer app wasn't really optimized for this incremental rendering. So let's compare the Glimmer app from before with a Glimmer app with 60 frames per second. Right. So the other one never finishes, by the way. But I think this is pretty cool. So with the incremental rendering, you can start seeing stuff. You can start using stuff right away. You don't have to wait for ever to everything to load. And this is sort of out-of-the-box behavior that can be achieved with bytecode stuff. And I think it's pretty cool. Yeah. Any question regarding all of this before I continue? Yeah?
How does it know, like if I have 100 components behind something, behind a button, how does it know that I need to only render the stuff that's before and not all the things behind it?
Well, I mean, you will normally use some sort of routing to indicate where you are and what needs to be rendered, right?
It's on the same route, but it's JavaScript enabled.
It's our what?
It's on the same route, the components,
Mhm.
but it's JavaScript only. Like if you click a button, a frame shows up from.
Yeah, that's happening with the, so if you go back, the update VM and the appending VM, they assign stuff to each other. So it's not only like dynamic attribute stuff it watches, but it's like stuff that needs to change. Usually stuff that happens in the UI when you click a button is a state change or whatever. The update VM handles all that for you.
No, but we are considering that those things that are not shown right now,
Mm-hmm.
they're not going to be rendered as soon as we load the big component.
Right. Yeah, so if you need a component that's not there in the DOM, the append VM will make sure that it gets there. That's how it works. It's all bytecode and it was just appended to the DOM. So on load, everything doesn't need to be there. It works as everything else, basically. I mean, you can have the same feeling in React or Ember or whatever. You can have a component that's not there, and then you can trigger it. It's the same. Yeah.
That's the same, but here you were saying that it will render it before it actually has all the components.
Well, I mean, it will split the browser tasks within, right? It's not like component by component. It's the task that the browser has to get through to render stuff.
Yeah,
right.
but the browser doesn't know that this thing is behind the button for a hit. It's just.
Yeah, but when you need it, it gets there. It's like everything else. Yeah, sorry. All right, let's not watch this again. Cool translation. Yep. So we have to talk a bit about how we use Glimmer here. So the thing is how to use something new and cool without having to refactor your entire code base or like just throw everything out. Like we have worked on our stuff for 3 or 4 years. Now we are sort of lucky enough that Glimmer is made by people that also works at Ember, and we use Ember here. So thankfully we get a lot of stuff like baked in. So the current rendering engine of Ember is what is called Glimmer 1, and what you've seen here is Glimmer 2, now Glimmer, because front end. And so we have some things, but we don't have everything. And we want to use this while still using our existing platforms. So obviously, components is what we're going to use here, right? We have components in applications, so we need Glimmer components. But we don't really want to recreate all the components or whatever. It's messy. And some frameworks has this approach of just releasing a major, and then you can choose to upgrade and work for 5 months on that, or yeah. So what we get is with every minor release, more or less, we get a new tidbit of Glimmer, right? So Glimmer itself is more or less done. The main goal now is to bake it into the framework, Ember. So right now we are on Ember 3.4, which means that we have these things. So right now, if we make a template-only component, so a component without a JS file, basically, it will automatically become a Glimmer component without us doing anything. And the same with named arguments is a way that didn't exist before in the framework to signal here's a dynamic change the VM needs to watch. So by changing our arguments to start with a @ we now utilize Glimmer this way. And then the last thing, if you have ever used Ember, you probably know it's handlebars. So a lot of people feel that's pretty old school because angle brackets is the shit. So we have that now, but not because it's the shit, but because that's how Glimmer components are. So by transforming our handlebars components to angle brackets, we also utilize that part of Glimmer. And currently there's a whole quest going on to bake everything into Ember, bit by bit, in a way that's backward compatible, and that, you can read that probably. It's really, but we can get there without throwing away our code base, or without destroying stuff. But with every minor release, we get a new thing, and then in the end, we have Glimmer as a more or less drag and drop your component into our code base, and we have all these exciting performance benefits, and so it's exciting, I think. That's all I have. So if you have any questions. Yeah?
What is angle brackets?
Well, it's like an HTML attribute. Starts with the, I don't even know what the sign is called. Less than, larger than. Yeah, so that's the way to do it in most frameworks these days when you put a component in. In Ember, it's handlebars. So it's a bit different.
Template syntax?
Yeah.
Also is the same as HTML? It sounds weird.
Yeah, well, they have to start with like uppercase. So it's a bit easier to differentiate. But it's a very long discussion with a lot of opinions. But I can tell you it's the shit. That's what we need to use. Yeah? Cool.
Relatively far, we've kind of seen Ember and React at the same time. You went and talked about VMs, the pen and the VMs. Probably the things that would add clarity is really what's happening a little bit inside the VM itself. Is that React basically watches on and on, compares, and then figures out what's the difference and computes what is rotated. But what's smart about Ember, sorry, it's not a question. I'm just taking one. What happens on the Ember is that there's no watch it on. Right? There's no such thing as watch it on. On the Ember, what it does is it uses those very important Ember feature, which is handlebars, to actually figure out the static components and the dynamic components to actually figure out in a smart way what are the changes. That's the gist. A lot of this.
Do you have a question, sorry?
I'm sorry, I
No.
just wanted to add clarity because he
Okay.
went on.
Because I think it's really good because the Ken is standing up there, so it's best to ask him a question if he has to answer it. So that's really good. No, okay. Is there some?
I do have one. So I just wanted some clarity on, like, when you say virtual machine, do you mean like they build a virtual machine in JavaScript for parsing?
Yeah, and it's super tiny, so that's good.
Yes. That's
Yeah,
awesome.
yeah, but yes.
Man, have JavaScript fail, right? When we use it to build virtual machine
Well,
to interpret languages.
surprisingly enough, it seems to work. But
Yeah,
yeah,
it's
it does tell about a lot about the state of JavaScript. That's
It's very meta.
yeah, true. Yeah,
What about the browser compatibility? How far back does it go?
I have no idea. Honestly, I could probably check it, but I have no idea.
Firefox and
Yeah, yeah, exactly. Yeah.
I think it's related to the other question. So the bytecode is not compiled on the browser, it's compiled in an engine built in JavaScript.
Yeah.
But then is that engine not very large?
No, it's fairly. I can't remember the exact size of it, but it's really tiny. Yeah. I mean, it's on GitHub, so you can check it out.
Cool.
Yep. Thanks.
Thank you, Kenneth.